function is going to call its that is the definition of recursive. So where we are going to use this kind of recursive function means. So it is applicable to I am going to take example for that. So it is applicable in factorial, mathematical problems. So it is good in factorial, finding of factorial of given number. So let us consider the number called 4 factorial. So I want the find I have to find the value for 4 factorial. How the calculations will be done will be this. So it is the indirect meaning. So I have to find the factorial for 3 factorial and that number. Okay. Again I need to find the factorial for 3 factorial. So 4 into 3 into minus 1, that is 2 factorial. So again 4 into 3 into 2 into 1 factorial. So finally the 1 factorial value will be of 1. So the value for 4 factorial is this. So what I have to find is 4 factorial. But indirectly I am finding 3 factorial, 2 factorial, 1 factorial. That's why the factorial of the given number is a good example for recursive function. So let us create the function here. So I am creating the function for the factorial. So I am passing the parameter as only one parameter I am passing because I have given only the value as 4. So the value is integer. So in here I am passing the value as 4. So here I am creating the function. So we need to find the 4 factorial values. So here I am creating the variable called sum. Okay, and initially the sum value will be of 1. So sum into n. So here 1 into n is calculated. But I need to find again the 3 factorial. So again I need to call the function. That is the factorial. Fact. So I need to decrease n minus 1. So what I am doing is sum is equal to 1. Initially I am setting the value as 1. So in sum is equal to sum into n. So I am going to calculate the value, that is 1 into n value will be of 4. So the values are stored in sum. So sum value contains 4. So again we need to calculate the factorial for 3 factorial. So that's why I have used the function called fact bracket n minus 1. So it is going to increase by 1. So I am giving the value as n minus 1. So again it is the value going to replace with 3. So sum is equal to sum. Sum contains the value of 4. Now the n value will be 3. Okay. So here the sum contains the value is 12. Again we are going to call the function with reducing of minus 1. So now the value n value will be moving into 2. So here the sum contains 12 into 2. So now the sum will be moving into 20. So again I am reducing I am again calling the function of factorial fact n minus 1. So here the n value is 2 minus 1. So again n value is replaced by 1. So sum is equal to sum into n. Sum value is 24 into 1. So now the value which contains the variable called sum is 24. Again it is going to move into the next line, that is the factorial of n minus 1. So n minus 1 will be of 0. So it is going to calculate with 0. So again it is going to add. So I need to check the conditions here. So I am giving the value n must be greater than of 0. Then only this will be work. So this is the working flow for recursive function. So it is applicable only in factorial, finding of factorial. No, it is applicable in finding Fibonacci sequence also. What does mean by Fibonacci sequence? So let us take the example. Fibonacci sequence or series. So the Fibonacci sequence is nothing but, so I am initially giving 2 values. So the third value will be of adding of previous 2 values. So initially I am giving the values minus 1. The second value will be of 1. What is the third value? So adding of previous 2 values, that is 1 plus minus 1, that is the value of third value will be same. Again the fourth value. So here I am going to add off third value and the second value. So this is the sequence of Fibonacci series. So this is also done by using the recursive functions. Thank you.